Hello and welcome for a new UnityFT Designer video tutorial. My name is Michael and I'm working for Electronic Assembly's development team.
Today's tutorial is designed to give an overview of the mathematical functions in the UnityFT series. The functions can be used within calculations. In this tutorial, I would like to discuss three topics in more detail: algebraic, trigonometric, and statistical functions. For each of these topics, I prepared a small introduction example with the UnityFT designer. Let's start with the algebraic function. The UnityFT series provides several algebraic functions. I would like to explain some of them using a quadratic equation as example. Pressing the Calculate button, we want to calculate 0 points of the equation. The result should be displayed as text. For this, I placed a formatted text. The Calculate macro is linked to the press event of the button. 3 register values have been created for the 3 coefficients of the quadratic equation and have already been preset with the correct values: 1, -4, and 3. Now, let's start with the calculation. For this purpose, we will use a quadratic formula. First, we calculate the discriminant and store the result in register R10. Since we expect a floating point number as result, we need a float register. We use the command vrf variable register float. To calculate the discriminant, we need the power function. Calculations must always be inside brackets. Therefore, we start with an open parenthesis. We use the power calculation for the power. This requires 2 parameters, base and exponent. The parameters are separated with a comma. We have defined all coefficients as registers in advance and we have given them a beautified name. We can now use this name. All basic arithmetic operations, plus, minus, multiply and divide, are also supported. The point before line arithmetic rule is also used. In register R11 and R12, we want to store the result of the 0-point calculation. We therefore need the root function sqrt. Finally, we just need to update the formatted text. This is done with the sfc command. Let's take a look to the result in the simulator. If I press a button, the 2 0 points, 1 and 3, are calculated correctly. Other algebraic functions like logarithm or exponential function are also supported. Besides the algebraic functions, trigonometric functions are also offered. By using sine and cosine theorems as an example, I would like to explain how to use them. A triangle with all angles and one side is given. We want to calculate the other 2 sides using the sine and cosine theorems. We have already entered all the given values in the register editor. The UnityFT uses degrees in the trigonometric functions. Additionally, there are 2 calculation functions, rad and degree, which convert between radians and degrees. Again, we use a float register and store the result in the registers R10 and R11. For the calculation of B, we use the sine theorem. We calculate C with the help of the cosine theorem. We present the 2 results using the formatted text. Let's have a look to the result in the simulator. By pressing the button, the other 2 sides of the triangle are calculated and the result is displayed. The tangent function as well as the arc functions are also supported. Another block of mathematical functions are the statistical functions. We can generate random values and calculate minimum, maximum and average values from a set of values. For this, I have prepared a small project. First, we want to create 4 random values, 3 of them as integer and 1 as float value, and display them. Afterwards, we want to calculate the minimum, maximum and average of them. Let's start with the random values. we assign a value to register R1 with the calculation command run. If nothing is entered within the brackets, a random value between 0 and 65,535 is generated. If you specify two values within the brackets, a random value is generated that is within the defined interval. If only one limit is specified, it defines the maximum value. So far, we have always generated integer values, because we have assigned the random value to an integer register. If you use the vrf command instead, a float random value will be generated. We now output the created values as text with the sfc command. Finally, we want to output the minimum, maximum and average values. Since we have mixed integer and float values, we decide to output the calculated values as float as well. If integer and float functions are within a calculation, we need to specify how they should be treated. We want to use a float calculation, and therefore we have to use the calculation command int before each access to an integer register. This specifies that an integer calculation follows, but it should be returned as a float value. For our calculations, we use the function min, max, and average. We output our calculation directly as formatted text. Now let's start the simulator again. Every time I press the Calculate button, the random values change. You can see that the second random value only moves between 20 and 30, and the third only up to a maximum of 30. The other two have only a 32-bit signed variable limitation. Finally, let's deal with the increment and decrement. Each time the button is pressed, the register is to be increased or decreased by 1. For this purpose, the two buttons were connected with the increment and decrement macros. We use the command sfc again to output the new register value directly as text. First, we consider the post-increment and post-decrement. This means that the register value changes after the calculation is completed. Let's take a look to the result in the simulator. If I press the increment button, the register value R1 increases as expected. The output remains unchanged because the increment was applied after the calculation. So the text always shows the state before the increment or decrement. We now want to change that and use the pre-increment and decrement. In the simulator, we can see that the register value and the displayed text change at the same time. The UnityFT offers a whole range of mathematical functions to perform calculations. In this way, simple mathematical operations can be performed.
I hope you enjoyed today's UnityFT video tutorial. Maybe you have time and play around a little bit with our sample projects and enjoy our other tutorials.